Hello and welcome to my Programming in Python primer. My name is Mr. MacMillan, and I will be your guide through this very brief introduction to programming in the Python language. Now, quick question before we start. What is programming? Programming is the process of telling a computer a sequence of instructions that you would like for it to execute. And we accomplish this by using specific languages which are designed for computers to be able to understand our commands more easily. So we use languages like Python, for example, to write code that is very easy for us to understand because it's written in English words, and then the computer will take the words that we have written, translate them into machine-readable code, and execute the instructions as we have laid them out. So Python is one of the easiest programming languages to pick up and to work with, so that is why we are going to be doing a brief introduction to that today. Before I get to any actual code, there's a very few pieces of useful terminology that we will be using throughout the introduction today. So the programmer is the individual who is responsible for the creation of a program. We are going to be filling that role today, writing our code. The user is the individual who is interacting with the program while it is running. Running is while it is doing what the programmer has told it to do. Today we will be filling both the role of programmer and user, but it is possible that if you show your code to someone else, that other person will be the user instead of you. The console is the area where the user is going to interact with the program while it is running. That is where both input and output will occur. Input is any information provided by the user to the program while it is running. Generally, this is going to be typed into the console via the user's keyboard. And output is any information that is produced by the program and put into the console for the user to see. So input and output, that is how information makes its way to and from the user from your program. Now, I am going to be using a website called Replit to write and run code today. It is free for personal use. It is fully online, so feel free to follow along if you like. Here is the website. You just have to make an account. So here is what Replit looks like. On the left side, we have our code writing area. Currently, I have 2 empty lines. On the right is the console, as I said earlier. This is where our input and output will be taking place when we actually write code. So, the very simplest program that you can write in any language is the Hello World program, where you are going to instruct your code to greet the world around it. We are going to make our programs produce output by using the print command in Python. To use print, we say that command, put it in our code, and then we put the text that we want displayed inside of the parentheses, inside of a pair of quotes. It should look like this, print hello world. So if I go over to Replit and I print hello world. There we go. Alright, so I've written my line of code, and then when I click run, my output appears in my console. And there we go. Very first program, super simple. All right. Now, it would be nice if we could make our programs, instead of greeting the whole world, if it could greet us specifically by name. But in order to do that, our program needs to know what our name is. So we need a couple of things to accomplish this. One, we need a way to retrieve information from the user. We need to know how to do input. And second, we need to know how to save that information that we've gotten from the user so that we can use it later. So we can get information from the user by using the input function. The input function is going to function very similarly to print because you are able to have a message displayed to the user. Just like with print, you put it inside those parentheses, inside of a pair of quotes. The input function will display that message, and then it will wait for the user to type something into their keyboard and hit enter. Generally, we are going to want that message that we put into our input we want it to be indicative of what the user is supposed to enter. So to get our user's name, we might have an input like this, input, and then our message is enter your name. So if I add that to my code, input, enter your name, and I run this, it says hello world, enter your name, Mr. MacMillan, and once I hit enter, my code has finished. Now, I'm not actually doing anything with that input, but it is running. So now that we know how to get that information, we need to know how to save it. And we're going to do that with something called a variable. A variable is a named piece of information that our program is able to access. Think of it as a box that we've put a label on so that we can access from that box whenever we want to. They let us store data so that later in our programs we are able to use them. And in order to exist, variables need two things. They need a name and they need a value to have inside of their box. So there's a few rules around naming. First, we want to make sure that the names that we use are descriptive. Variable and or function names like a or my variable don't mean anything. So we want to use names that actually describe what they are for. In this scenario, we're making a variable to store our user's name. Maybe a variable name like name or username would be great. Rule 2, we want to use underscores instead of spaces. If you try to use spaces in variable names, Python gets mad. So we want to avoid that. We want to use underscores instead of spaces. Rule 3, we want to use only lowercase letters. This is not a hard and fast rule. It is not going to crash your code if you do not follow Rule 3, but in programming, capital letters are generally reserved for a more specific purpose, so we want to exclusively use lowercase letters. And Rule 4, the very first character in your variable's name cannot be a number. Your names can include digits, just not as the very first character. So rules 2 and 4 here are rules that if you break them, your code will not run, where rules 1 and 3, your code will still run. Those are just best practices. It is very good if we follow all 4 of these rules when we make variables. So now that we have both of those things, or actually we just have the name, we can make a value for our variable by assigning it a value using an equal sign and the thing we want to give to it. For example, I could make a variable called my_var, and then it can equal hello. So now my var will equal hello whenever I want to use it in my program. Now, we have both the things we need to get our user input. We've got our variable that is in the pink, somewhere to save the information. Our variable is called name, and we are getting information with the input function. We say name equals input, enter your name. So here we can say name equals input, enter your name. All right, now we need to know how we can actually use that variable, actually use the data that is being stored there. Once we have stored that information into a variable, we are able to access the value stored inside and use it in our programs. Depending on the type of the data, there are different kinds of operations that can be performed on this variable. Now, so before we can talk about how to work with that name variable, we need to talk about our data types. There are 4 primary data types that we are going to care about in Python. Integers and floats, which are both numbers. Integers have no decimal places, floats have decimal places. Strings, or str for short. Strings are a sequence of characters contained within quotation marks. You can think of these as just words, and that includes things like special characters, exclamation points, question marks. Any other character that you can type on your keyboard is valid as long as it is inside of quotation marks. It's part of a string. And booleans, shortened to bool. These can only be true or false, and these will be more relevant a little bit later. So, based on the type of data that we have stored in a variable, different operations are available. If we want to do math, we need integer or float values, we need numbers, and we can do things like addition, subtraction, multiplication, or division. There are other mathematical operations that are allowed, but those are the 4 standard ones. If we're working with strings, we can do a process called concatenation. This is done with the plus operator, so the plus is used for both mathematical addition and concatenation when we're working with strings. And concatenation is when we just add one string to the end of the other. We're just smushing them together into one longer string. So now that we have all of this information, we can actually greet the user once we have their name. We've got their name variable equals input, enter your name, and we can print hello, and then plus name plus an exclamation point, and those 2 pluses will do concatenation. So back over on our code, I'm going to remove that hello world, and I'm going to add a new line, say print hello plus name plus exclamation point. And I've included a space here, because if I don't include one, it will not be printed out. So if I run my code, I asks my name, Mr. MacMillan, and it says hello, Mr. MacMillan. There we go. We've done it. Alright, so that is how we can get one kind of user input. Something to keep in mind is that the input command will always give back a string typed value. So we'll always give a string type no matter what kind of value was entered. So if I just entered the number 4 and pressed enter, it's still going to be treated as a string. It'll just be 4, like this. So let's add to our program an input for the user's age, and then tell the user how old they will be in 5 years. So I'm going to make an age variable, have that equal input, enter your age, and then we're going to print in 5 years you will be age plus 5 plus an exclamation point. So let's add that to our code and see what happens. Age equals input, enter your age, print in 5 years you will be plus age plus 5 plus an exclamation point. Alright, so let's see what happens when I run this. Let's try that again. Alright, I'm going to refresh my page. See if it works this time. I had lost track of my changes. Age equals input. Enter your age. Print in 5 years you will be plus age plus 5 exclamation point. Close that. Oh, I missed a plus sign here. Alright, try running it again. There we go. Enter your name, Mr. MacMillan. Hello, Mr. MacMillan. Enter my age. I'm just going to say I am 5 years old. That's not the truth, but we'll see what happens. Alright, I've had an error on line 4. So on this line, I didn't mean to do that. There we go. In 5 years, I will be age 5. That's the line. And my error is a type error. You can only concatenate str to str. So the problem is with this plus sign, we're adding a number 5, and if we remember from last time, input is going to be a string, so we're doing a string plus age is actually a string, plus 5, that's an integer, and Python does not like it when we try to use a plus sign with a string and an integer. It's going to get mad, that's not going to work how we want. So if we break down how we want these pluses to work, we want this middle plus sign in pink to do mathematical addition. We want to have the age number plus 5. And then we want to do concatenation with the 2 outside plus signs that are highlighted in green here. And in order for mathematical addition to be allowed, both of the values must be numbers. So since input gives us a string, age as a string, we need to turn age into a number. In Python, if we want to change the type of a value to a different type, we can do a thing called typecasting. To accomplish this, we put the type we want to cast into, followed by the value we want to change in parentheses. So if we wanted to turn age into an integer, we would say, I want to turn it into an int, and then in parentheses, the thing that I'm trying to change. So age turned into an int. Now, unless we save this change somehow into another variable, into the same variable, however we want to do it, these changes are temporary. So this will give us the numeric value that is stored in the string age, but it will not change age forever. Age will still be a string unless I physically, or not physically, but choose to change age. And since we are going to be using user input to get a number here, and this is a very common thing, a common practice is to put that typecast around the input, which will turn whatever the user types in into a number and then save it into a variable. So we don't have to worry about the string. We'll just say our age variable equals int of whatever the user inputs. So the user types in a number, it immediately gets changed into a numeric value and saved into a variable. So we can actually do math with it now. So if we bring over here, age equals int input, now age is actually going to be a number, so age plus 5 will actually do math. Now, we're also going to want to add some parentheses around this to make sure that it's still, or that it gets prioritized, just like in normal PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction from regular math class, parentheses in programming are going to prioritize whatever is in parentheses. So I want to put my age plus 5 in parentheses to make sure that that addition happens first. So if I run this, let's see what happens. Enter, my name is still Mr. MacMillan. My age, still going to just say it's 5. All right, we are still getting that same error. Can only concatenate string, not int, to string. And that problem is happening because that whole chunk, age plus 5, this is all still a number. And we're trying to do concatenation with this and this plus sign. So in order to fix that, we're going to do another typecast. This time we're going to turn this chunk from int to string so that all three of the things that we're trying to add are strings. So if I say str and then have that in front of the parentheses we added for this, that will typecast that chunk into string. Then we'll have a string value plus a string plus a string. That will solve our problem. So if I say str here and try to run this, my name is still Mr. MacMillan. Enter my age. If I say 5, in 5 years I will be 10. There we go. Now our code is working as we want it to. All right. So moving on to our next topic, often we are going to want to make decisions in our programs. And we can accomplish this using an if statement. If statements are going to use this structure. If, and then some condition, and we're going to have a block of code to run if the condition is true. So this true is one of the two Boolean values. Booleans, if we remember from the beginning, can either be true or false. There's only those two options. So if our condition is true, this code will run. And we'll talk about building conditions in just a moment. But quick note about our structure. This indentation that we see here, this tells Python what is and is not inside of this if statement. Any lines that are indented belong inside of the if statement, so we can have more than one line as long as they're all indented. And as soon as we see something that is not indented, the statement has ended. Everything after that is outside the if statement and will just continue as normal. Alright, so building conditions. When we're building conditions, pretty much always we are going to be comparing one thing against another thing. We can do this with our 6 comparison operators, which are equals equals, which checks if the two values are equal to each other, exclamation point equals, checking if things are not equal, we have greater than less than, and we have greater than or equal to and less than or equal to. Keep in mind that our equals uses 2 equal signs, because only one equal sign is how we give a variable a value. We need 2 equal signs to do that valid comparison. And in order for all of these to work correctly, values of matching types need to be put on both sides of these operators. So what we're going to do, we're going to build a rudimentary guessing game. We're going to make a variable equal to a number, and the user will try to guess that number. So I'm going to say my secret number equals 7. I'm going to get an int input, save it into a variable called guess, and if guess is double equal to secret number, we'll print you got it. So I'm going to replace the code that I have here. I'm going to make my secret number equal 7. You do not have to use 7. I am choosing to use 7, but you do not have to use that same number. Use whatever number you choose. We're going to say guess equals int input, enter a guess, and then if guess is equal to, and remember we want 2 equal signs because we're comparing, if guess is equal to secret number, notice that we have the ability to autofill. It is a very handy feature of Replit and many other code writing softwares. If guess is equal to secret number, then we want to print you got it. Alright, so if I run this, if I enter a guess and I say 7, it tells me I got it. Awesome. Now what if I run it and I don't say 7, I say 4? Then my code just ends and doesn't give me any feedback. That doesn't feel great, so let's add a little bit of feedback. We can update this to add a new piece of code called an else to run code when that condition, if guess is equal to secret number, when that's false, we'll run a different piece of code. So if that's true, we'll print you got it, but if it's false, we'll print sorry, try again. So we're going to exit our indentation, we're going to say else, and then we're going to print sorry. I'll say sorry not this time. So now if I run this, I say 7, 7 is still correct, and if I say 4, 4 is not correct, so it tells me that I got it wrong. Nice. Alright, so we can make this even better though. If we add something called an elif in the middle, because we're kind of combining the words else and if, we're smushing them together into one word elif, we're going to give even more information to the user. We're going to keep our if the same. If our guess is the same as secret number, we'll print you got it. Otherwise, if our guess is less than our secret number, we will print that they were too low. And in our else, meaning both of these were false, if we didn't get it the same and guess was not less than, guess has to be bigger than secret number at this point, we could say that they were too high. So let's make those changes here. So I'm going to add my elif. Guess is less than secret number. Print, and what did I say? You were too low. And then else, change that message to you were too high. Alright, so now if I run, if I say 4, it'll tell me that that guess was too low. Now if I run it again and I say 9, that guess was too high. And if I run it again and say 7, I have finally gotten the answer correct. Wonderful. So we have a very rudimentary guessing game, but we have to click run every single time I want to guess a new number. There's got to be a better way than that. Now, before we get to that better way, just a bit of more information on this if statement. Once again, if this condition was false, then we will check this second condition. If that one is false, we'll run the else. If either one of these was true, nothing below it will run. Only one of these is ever going to run. Additionally to that, you can have as many elifs as you want in between an if and an else. Anywhere from 0 to infinity. You can have a whole bunch of elifs. As long as they're checking different conditions, that is totally fine. So you can have as many elifs as you want. You don't have to have any, but if you do, you can go absolutely hog wild, have as many as you want. Now, back to what I was saying before. Very often in programming, we are going to want to perform an action multiple times. This process is called iteration. For our guessing game, it's really hard if you only have that one guess. So, in Python, the simplest way to perform iteration is with a for loop. We're going to put our guessing game into a for loop, which will let us guess multiple times, see if we can get the right answer that way. So, for loops follow the following structure. We say for a name I, in range, the number of repetitions, and then indented, the code that we want to repeat. So if we go back to our guessing game code, we want to make a loop to give the user 5 guesses before they lose. So we're going to take that whole chunk of code, we're going to put it inside of a loop for I in range 5, and then a colon, and then all of this indentation shows that this code is all inside of this for loop. And then we have even some double leveled indentation for these 3 prints that are inside the if, elif, and else. So that first layer shows that all of this is inside the for loop, and those all show that those lines are inside of those control structures. So we are stacking that indentation to show what goes where. So let's add that for loop to our code over here. So it goes after our secret number. We're going to say for I in range 5 to give them 5 guesses. And then one handy feature in many code development environments, I'm going to select all of the lines I want indented. And then if I press tab, that will indent all of them at once. I don't have to go line by line. Very, very convenient. So if I say for I in range 5, guess is int input, enter a guess. If guess is secret number, print you got it. If it was too low, say so. Otherwise, it was too high. So let's run this. Let's say I enter 4, too low. 6, too low. Okay, let's shoot the other direction. Let's go 8, too high. Okay, well, 6 was too low, 8 was too high, so 7. I got it, but it's gonna keep asking for guesses. I've entered 5 guesses, but I got it on my 4th guess. So there's gotta be a way to solve that. It keeps guessing, it keeps asking for guesses even though we got the right number. So something that we can add is the break keyword, which instantly is going to end a loop. So in our if statement for getting it correct, if guess is equal to secret number, we'll print you got it, and then we'll add a line that says break. And when Python sees this break keyword, it's going to find the loop and say, all right, I know you still had loops going, but you're over now. Loop is done. Do not matter how many more there were. Loop is just going to end. So if I enter a guess, if I enter 7 as my very first guess, it'll tell me I got it, and then my code will just end. Very good. Now if I never get it correct, if I guess 1, 2, 3, 4, and 5, we're told that we were too low all 5 times, and our code has now ended. Game over. We have lost. Alright, and there are numerous ways to make this game better. We can have a random number for our secret number. We could tell the user how many guesses they have left, but we're running a little low on time, so that's going to be it for our introduction to programming. Thank you for tuning in. It has been a pleasure, and I hope you enjoyed.